It tells us that Will and Chris start a joint venture in which working together the value they can create is given by, and we see that the value function is determined by how much effort they put forth. So immediately we identify this as a free writing question, and we're going to go ahead and skim through this and look at what the actual question is asking us. It says, how much lower is total surplus, which is value less the cost of effort, if Will and Chris simply split the total value evenly and treats widget production as a non-cooperative game and maximizes their individual surplus given the behavior they expect of the other, compared to the case where they work as a team. So we're going to find total surplus when they free ride, total surplus when they work as a team or cooperate, and just subtract those two numbers. We see that its answer choices don't actually have a number, so in this case we're going to kind of leave it unsolved as far as we're not going to solve for the ln in the end. We see that the answer choices have the ln in it. But a lot of the key to these new questions and these new topics are being able to match what we know to be the answer to his answer choices. So if you did go ahead and solve this all the way out for a number, you can plug into your calculator his answer choices and match up that number, and you'll get the right answer. But we're going to leave it in the form that he's put it, just to show you kind of how he's thinking about it. So we're going to subtract the total surplus when they free ride from the total surplus when they work as a team. In other words, this right here. Well, free riding, what does that look like? For one of the people, because they're identical people, we see that there's symmetry in this question because they create the same amount of value represented by that 20, and their costs are both 2 times their level of effort. So for Will, we only need to have his cost of effort out there, and we can go ahead and take this derivative. We'll simplify first, take this derivative with respect to EW. We do that, we solve down, and we see that EW is going to be equal to 5. Again, because I said there was symmetry, we know that it's also going to be equal to EC. So we can go back and plug in 5 to our total surplus when they're free riding, and we can solve this down. And this is the lowest we'll make it. Now this is just a number, right? You can plug in the ln of 5 to your calculator, times it by 40 and minus 20 and get just a number. But we notice that he hasn't done that, so we're going to keep it in this form. 40 times the ln of 5 minus 20. Now let's look at when they maximize total surplus. Well, now we can just write total surplus. If we were going to work from one person's point of view, say Will's, we would divide. So if we had total surplus Will here, we would divide the whole thing through by 2. But that's the same thing as just not dividing it at all by 2 and maximizing total surplus. So understand that, you'll get the same answers. We take the derivative with respect to EW, or either variable, because they're going to be the same. And we solve for EW in this case to be equal to 10, and EC we know of course is going to be equal to 10 as well. So now we can look at our total surplus when they cooperate just by plugging in 10 for EW and EC. Again, simplifying to this point to get 40 ln of 10 minus 40 is a total surplus when they cooperate. So again, at the beginning of the question, we decided that we're going to do the total surplus when they cooperate minus the total surplus when they're free riding. And we know both of those are as follows. So we need to make sure to distribute through the negative sign correctly to get 40 ln of 10 minus 40 minus the total surplus when they free ride. So we distribute through that negative sign to get minus 40 ln of 5 plus 20. Now we can match it up to an answer choice on the test, which was this right here.